Hey everyone, we're back at it to finish off 7.7. This is page 3. These equations have two inverse trig functions involved. So how do we tackle those? The first thing I'm going to do is algebraically isolate that x. So I'm going to have x equals. So in other words, I'm moving that sine inverse to the other side, which means you got to do the sine of that entire side. So yeah, you end up with one of these like trig function within a trig function type things, right? And notice when I move that sine over, it's just sine, not sine inverse, right? Sine inverse on one side, move it over, it's sine. Okay, and we've done those problems before, if you recall, might look a little familiar where we draw them out. So I'm drawing cosine inverse of 3/5. And so cosine is x over r. So there's my 3/5. I call that theta. And then I can get the y by Pythagorean theorem. Y squared plus 3 squared equals 5 squared. Or you just recognize it's a 3, 4, 5 triangle, right? But if you solve this down for y, you'll get y equals 4. Okay. So cosine inverse here, that's what I'm calling theta. So this is the same as sine theta. All right. And then now look at your picture. What is the sine of theta? That's y over r, or 4 over 5. So my final answer is x equals 4/5. Right. So those that have multiple trig functions in them, you'll have to draw a little triangle. And maybe use some identities like in this next one. Okay, so this is probably the hardest one of the section because we have the trig functions on the same side being subtracted. So my first step, I'm going to move that tangent inverse to the other side, just like adding it to both sides. So I've got sine inverse of x equals negative pi over 3 plus tan inverse root 3. Okay. So I just move that guy to the other side by algebra, adding both sides. Tangent inverse root 3. Okay. Now I'm going to isolate the x by moving the sine inverse out of there. So now x is equal to, if I get rid of that sine inverse, it just becomes sine of the entire other side. So I'll put everything in parentheses. And that looks like a mess, doesn't it? It does to me. But what I'm going to do is focus now just on that piece right there. Let's draw that out. So if I go to the side here, tangent inverse of root 3. Tangent is y over x. So that's root 3 over 1, if I think of that as root 3 over 1. And then that's my theta. That's what tangent inverse root 3 equals. And then by Pythagorean theorem, I can find my third side. If I call it r squared equals 1 squared plus root 3 squared. Right? If I just work that out real quick, that's 1 plus 3, just 4. Square root of 4 is 2. Or you might know that triangle, 1 root 3, 2. Pretty common triangle in trigonometry. Okay, so put that on the back burner for a minute. But what I'm going to do is now take this and replace it with my picture, because that's equal to the theta in my picture. So I now have sine negative pi over 3 plus theta. That makes it a little bit simpler to work with in my equation here. Okay, now check this out. You have sine of two things added together. To deal with that, use an identity, right? The sum identity for sine back from 7 point whatever when we did that, right? Remember how that works? It's sine of the first angle, cosine of the second, plus cosine of the first angle, sine of the second. Okay. Now we are in business here because sine of negative pi over 3 I can find on my unit circle. So if I go back to my unit circle for that, negative pi over 3 is the same as 5 pi over 3. So we're right down here. Right? And so the sine is the y coordinate negative root 3 over 2. The cosine is 1/2. Right? So sine negative root 3 over 2 is, sorry, sine of negative pi over 3 is negative root 3 over 2. And we got that, okay. Cosine theta is the next thing. How about cosine theta? Now I'm gonna go to my picture here. Cosine of theta is x over r, right? So that's 1 over 2. Cosine negative pi over 3, that's back to the unit circle, same location, right? That's where we saw that it was positive 1/2, right? That's from the unit circle. Cosine negative pi over 3 is equal to positive 1/2. And then finally, sine theta, I got to go back to my little triangle here. Sine theta is y over r, root 3 over 2. Okay, now we just have numbers. So now we've got negative root 3 over 4 plus root 3 over 4. Oh, well, those are the same, but one's negative, one's positive. That's just equal to 0. All that work, the answer is 0. Okay, I'm pretty confident that we did that right, but I could always check it if I plugged in 0 for x and then just work that out, maybe with a calculator or something, and see if that checks out to 0, which it does. Okay, so there you go. Chapter 7's done. 5, 6, 7, we've done it. 3 chapters down, 1 more to go. Hang in there, keep going. Send questions my way if you have any. Okay, I'll talk to you later. Thanks, bye.